Hello everyone. Today is the third lecture on SQL Server. Like last video, we studied about the system databases and the syntax to create the table. But while creating the table, we need to mention the data type of the column that we are creating. But there are many data types. Like today in this video, we'll study about the data types in SQL Server. What all data types we can store in the table. Okay, let's start with video. Okay, data types in SQL Server. We can simply go to uh, Google and I'll show you. Type in SQL Server. We'll get the Google output here, and like you can directly go to the SQL check. These are quite a helpful website. So if you want to learn about the SQL Server, Microsoft SQL Server, like everything you will get here in a very descriptive format. We don't be need to make notes out of any topic. Like we can go type the topic name, and like we can just simply click here. This is the introduction, and like we can get the list. The support the following data types. One is numeric, another one. This is a extra. We can ignore this. Then data to store the data and time. We have date and time data type, string data type, character string data type. To store the special type of strings, which would be having the numbers also. Then binary string data type and other. We can ignore this. We won't be like using much. In numeric data type, we'll be using that there are bit, tiny int, small int. We'll see one by one. I'll just copy those data types that we'll be using most of time. Numeric, then date time. We won't be using date time offset. String. In string, string will using character, varchar and text. Text will not use much, sometimes depends on case, but varchar is the widely used. After that, character strings, Unicode character strings. In Unicode character strings, most of time we'll use n varchar only. Binary, we won't be using much in production environment, but these are the good to know. In today's video, we'll only see about numeric data types. We'll only see about numeric data type only. In numeric, there are bit, tiny int, small int, big int, and decimal. All of these are will store numbers only, but every data type has its own different features and limitations also. We'll see bit. Here we have a tabular format. As I say, we don't need to make notes for SQL. We can simply go to sqlcheck.com and we'll get the everything. For bit data type, it can only store 0 and 1. 0 and 1 value only we can store. None other than 0 and value. Only 0 and 1 we can store. It will take 1 byte of data to store one row or one column. We can store null into it. Then tiny int. Tiny int is we can store 0 to 25, 255 number. 0 to 255. means only 256 entry we can store here. These 2 bit and tiny int are real numbers. Like we cannot store minus numbers into this. After that we have small int. It can range from minus 32,768 to plus 32,768, and it will take 2 bytes of data to store one number. And after that we have int. In int data type, we can int is a quite commonly used data type. Most of time blindly we will be using int data types, and in int we can store up to 2 billion rows, 2 billion numbers, plus 2 billion and minus 2 billion, like 4 billion rows numbers we can store, and it will take 4 bytes of data. After that begin will take 8 byte of data, and it can store really huge number, and like its limit is around like 19 digits, I think we can store into it, plus and minus range also. Mostly begin used in a data warehousing, where we'll be storing huge number of rows and we want to maintain ID of it and different unique ID of every row. Then we will use begin over there. And after that decimal, to store the decimal values like point values like 9.5 or 9 point, after decimal we can store n number of precision values. Depends on the precision, like how many numbers we are storing, will be having it will take a data. This does not indicate the row, like it 5 byte means if we specify any column in table with precision that 28 integers, 28 numbers we can store, it will take 13 bytes. It doesn't matter we'll store 1.0 or a really big number, every time it will take 13 bytes. Numeric is same as decimal, will not be used in numeric anywhere, and small money and big money, this will also will not use anywhere. Like these are the really important for us, and like we'll see in practical. Okay, the table, we'll create the table. Create table in test. Call 1 would be bit, call 2 would be tiny int, call call 3 would be small int, call 4 would be small int, then int int, call 5 would be big big int, and call 6 would be ECIMAL. We'll create this table, and there is one system SP under SP means store procedure. We'll learn about the store procedure, but here we'll use a system store procedure SP help. Basically this SP will give us the detail of the table. Here all the columns. Column 1 is bit, and it will take length. Length means the data, how much data it will take. Here it is 1 byte. Storage would be 1 byte. Length is 1 byte. For tiny int also it's 1 byte, and for small int it's 2 byte. and for int it is 4 byte. You can see here it's 4 byte, and for column 5 big int it will take 8 byte of data, and it will take 9 bytes of data. 9 bytes in for decimal would be taking for when we'll be having integer of 10 to 19 digit of length. We'll see about the decimal after this. Okay, and here is the precision and scale column. Now we can see the scale is 0 for every number, and this is the precision. Precision means how many digit that column can hold. Like in tiny int, it can store 3-digit number. We'll go to tiny int. Tiny int. The maximum number of digit it can store is 3. You'll get the idea, na? That precision means how many maximum number of digit that column can store. For small int, it can store maximum of 5 digit. For small int, 1, 2, 3, 4, 5. Only 5 digit it can store. For int, it will store maximum 10 digit. For big int, it can maximum store 19 digit. And for decimal, it is showing 18 and 0. But in for other cases, from bit to big int, we cannot change a scale and precision. But in case of decimal, we can change the scale and precision. Like we'll see here. We'll be adding one more column into the table. A alter table add call 7 decimal. Here we didn't specify the precision and scale. In that case, it will take default value which is 18 and 0. Means it will store the any number who has okay, I'll explain the precision, what is precision and what is scale. Decimal, precision, comma, scale. Precision means how many number of digits that column can store. We are clear about that. Okay, if I mention 5 here, and scale means how many number of digits it can hold after decimal. If there is 3, it means if we have a number like 5 digit any number 1, 2, 3, 4, 5, out of that this column can only hold 5 digits, and it can have maximum 3 digits after the decimal. Means after the decimal it can have here. Here, scale means how many digits it can hold after the decimal. And the default value for the decimal is 18,0. Means it will store the 18 digit number, but there would be no digit after the decimal point. Means if we declared it as a decimal, but it will store only integer values. It won't be able to store decimal values because the scale is 0. After the decimal point, it cannot store any number. Okay, like we'll declare the decimal with, it will hold 15 digits, and after the decimal it will, the 15 is the total number of digit it can hold, and the scale means the how many number it will hold after decimal point. If 6 means before decimal point it can only hold 8 numbers. I think 8, no, no, 6, 9 numbers it can hold. Maximum of 9 number it can hold. We'll see with SP help text. Here, look, And if we created it with 28 digit, you can see 28 and 6. It will hold maximum of 28 digit number, and out of these 28, 6 can be hold after the decimal point. And the length means the storage it is taking 13 bytes. Okay, we'll see here in decimal. We have created 28 precision. Na? Then 28, 29, 28. It will take 17 bytes. Okay. 20 to 20 to 28, it will take 13 bytes. If we have declared it at 29, it would be taking 17 bytes. Look, it will be take 17 bytes for each row. Okay, that's all about the numeric data type, guys. In next lecture, we'll see on date time data type. Thank you. Bye.